Suppose that we're interested in estimating the average earnings of 25-year-olds within the economy. Would it matter if we randomly sampled 100 individuals who are economics graduates from degrees across the UK in order to estimate the average earnings of individuals across the country? There is lots of evidence that degrees, and particularly economic degrees, raise average earnings. For instance, this paper from the American Economic Journal by Blemer and Mehta shows that studying economics raises earnings significantly. So if our sample is only made up of economic graduates, we'd expect to overestimate the average earnings within the population as a whole. So let's try and model this. Suppose that x is the random variable representing earnings within the economy as a whole. This is earnings of 25-year-olds in that economy. Then we can write down the expectation of x, which might be equal to mu x, and the variance of x is equal to sigma squared x. Now, we don't observe observations directly from this population of x. We observe it from a subpopulation, which let's define that as y, which will denote as the earnings of 25-year-old economics graduates. Now we know that there is a return to economics degrees, so let's suppose that the expectation of y is equal to some multiple of the expectation of x. Let's denote that as a times by the expectation of x, or a times by mu x. Now we randomly sample 100 observations from a list of graduates from economics degrees. So we're going to get 100 observations of y. So our observation is going to be y1, y2, y3, all the way up to y100. And the question is, if we use the sample mean, which remember is equal to 1 over 100, times by the sum from I is equal to 1 to 100 of yi, will this give us unbiased estimates of the average earnings of 25-year-olds as a whole? Now, to evaluate this, if the sample mean is an unbiased estimator, it follows that the expectation of the sample mean will be equal to the true population parameter we're looking for. So we need to take expectations of our sample mean. So the expectation of our sample mean is going to be equal to the expectation of 1 over 100 times by the sum of those observations of yi. Now, 1 over 100 is a constant multiplier of everything inside the expectation, so we can take that 1 over 100 outside of the expectation and rewrite this as being equal to 1 over 100 times by the expectation of the sum from I is equal to 1 to 100 of yi. We also know that the expectation of any sum is equal to the sum of the expectations. So here we've got the expectation of y1 plus y2 plus y3 all the way up to y100. So we can rewrite this as being equal to 1 over 100 times by the sum of all of those expectations. We know from the fact that the observations are identically distributed that the expectation of yi will just be equal to the expectation of y. So since the observations are identically distributed and randomly drawn from the population, we can write that the expectation of yi is equal to the expectation of y, which is just equal to a times by mu x. We don't know what a is, but it's some multiple of the expectation of x. So we can replace these expectations of y's with a times by mu x. So we rewrite this as 1 over 100 times by the sum from I is equal to 1 to 100 of a times by mu x. Now, a times by mu x is a constant. It's just the expectation of x in the population as a whole. A is some constant multiplier. So we're adding up this constant 100 times. So that will give us 100 lots of that constant. So we'll have 1 over 100 times by 100 lots of a times by mu x. Now the hundreds that we've got here cancel, giving us that the expectation of our sample mean is just equal to a times by mu x. Remember, a is how much on average economics graduates earn more than the population. So if a is greater than 1, then the economics graduates earn more than the population. If a is less than 1, then economists earn less than the population as a whole. On average, there's lots of evidence that economics degrees increase average earnings, so we'd expect a to be greater than 1, so we'd expect the expectation of y bar to be greater than the true population average mu x.